Good afternoon. My name is Michael Epprecht. I'm a cloud solution architect in the PDS team inside Microsoft. Well, what does this PDS team do? We're a team, some of you who've been long partners with Microsoft will probably know it as the OEM team. Our remit or our work has changed a little bit, and we are there to work with partners, independent software vendors, independent hardware vendors, OEMs, people who make sensors, who make PLCs, who make anything to do with IoT. We're there to help them to connect their things to the cloud. Before that, I was in the global black belt team doing IoT, mostly on the sales side. Been Microsoft 12 years. Before Microsoft, I worked for a small little German company with turquoise color in the logo called Siemens, doing industrial process control and automation. Guess what we're doing today? Industrial IoT is the same thing I did 15 years ago, except I've got the cloud now. And it's actually interesting. Still the same protocols, plus one or two or three more protocols. Most of the tools haven't changed much. It's still relatively hard, and it's a weird environment if you come from an IT side. So I'm going to look at this whole industrial Internet of Things side, how to make it real. You'll notice I do not have a PLC here on my table. It's too short time, 45 minutes. But I will show you what I'm running at home, and I'll explain exactly how I connected that, because that is connecting something very real world. Good. Whenever I show this slide, I keep on saying business, and whenever I get called into customers, either in my old role or my new role, the first thing I ask is, I want to speak to business and I want to understand their problem. And especially in industrial automation, you have to talk to the business. And the business is the production manager, the production team, the OT, operational technology guys. It doesn't help when IT tries to force OT to do something. Those two teams have never worked with each other. They're the biggest enemies within a company. And OT and IT, if they disagree, OT wins. Why? Because OT runs the company. IT is just those guys looking after Windows and Office, is the perception. So you have to get OT on board. If operational technology says no, it's no, because they are the ones who are producing the goods for the company or helping it. And this is the challenge. Microsoft, we've always dealt with the business side called IT, not the proper business side or the business decision makers. And everyone says, well, what is Microsoft doing in industrial automation? I'll touch on a bit that later. But that's the most important thing. If you're going to do industrial IoT, you better be speaking to OT and production, otherwise you can forget it. If you're talking to IT, you can talk yourself blue in the face because they're not going to be able to help you much because they'll be just chased away. Good. Now, we've all heard about this Industry 4.0, and everybody keeps talking about predictive maintenance as being the answer to everything. It's nowhere on the slide, predictive maintenance. Industry 4.0 is really networked manufacturing, taking all the data that you've got from all the various systems and making your production clever. Yes, maybe predictive maintenance or preventative maintenance might be good, and it might be part of that process, but it's getting the data from all those different systems. I've always said IoT is the world's largest integration project. In industrial IoT, it's even more because you're integrating even more. You're actually integrating to anything and everything in a company. From the manufacturing execution system to the ERP, to the supply chain, through to the factory floor, to the Bluetooth devices on the pallets on the factory floor, to the machines, probably to the HR system, all the way to the sales system, because it doesn't help that you're running a 100% efficient factory if you're producing stuff that the customers aren't buying. That customer demand determines a lot of what happens in a connected factory. Because connected factory for a car manufacturer means I don't have to produce 5 cars behind each other of exactly the same product, where I'm producing a certain, let's call it a BMW 320i, 5 or 10 after another, because logistically it's easier to say we just put a rack of 320 windshields there, and they will then get picked off. The big thing with Industry 4.0 is if the factory is capable of producing unique things right behind each other on the same machine. So in effect, the product that's being produced tells the factory and the machines in the factory what needs to happen to it. And that is where it starts getting interesting, because then you can have an orange car, you can have a green car, you can have a pink car, and the factory can produce it. Why? Because it doesn't really matter, because each product, everything that's coming off the production line is unique, but the factory is clever enough to be able to do that without having to, have to ask the manufacturing execution system what I need to do to this. Because the amount of data that's starting to flow in these type of connected factories is monstrous. And that is also one of those challenges. Now, if you take somebody like a car manufacturer, a German car manufacturer, they've got on their factory floor wireless Ethernet, 2.4 gigahertz. Everyone says, just let's connect everything wireless. Because Ethernet, plug in a Ethernet cable is too much, and putting it onto a factory floor is also hard. The problem is, Bluetooth is also in 2.4 gigahertz, down in that frequency range. They've run out of capacity on the factory floor in the 2.4 gigahertz range. So everybody who's bringing in pallets with Bluetooth, all the devices who are talking Wi-Fi, especially the IoT devices that they've got on their factory, they actually can't get a word in edgewise anymore because there's so much interference. So now they've said all new components have to be running 5 gigahertz. They've worked out by April next year, the 5 gigahertz network will be saturated. So, I mean, those are real world problems. That's why when you walk into production and say, hey, we can collect all your data and we can do everything with your data, they'll ask you, okay, how are you going to get it off my factory floor? Because that's the hard part. And these PLCs, which I'll touch on a bit later, some of them have still got a 10 megabit network connection, or maybe 100 megabit. If you're lucky, there's no gigabit in PLC world. And the routers and the firewalls and everything in that environment are running 100 megabit switches, because they were installed 10 years ago, because in a factory, once you install something, you don't touch it, you don't screw with it, and you don't upgrade it, because otherwise you screw with a certification and you'll break something. So this Industry 4.0 will require that the factory floors get changed drastically. And that's a challenge. We're trying to bring this cool technology and put it onto this old stuff. And anybody who's ever tried that, you'll notice it's very interesting to do it. So the challenge of making all this thing networked is actually the network in the factories these days. And that we're starting to see with even the smallest customer. And this is the other big thing. Human beings will become decision makers, planners, and controllers. So the factory will decide itself what to do. Not predictive stuff, but based on basic rules. Yes, there will be influences of predictions where you might say, well, I'm predicting that this machine will fail in next Wednesday. Therefore, I know I need to replace components on it before next Wednesday. When can I tell the factory I need to take the machine down? Because if I'm going to wait until it breaks, we're going to have a major problem, because then the whole factory is going to come to a standstill. We're going to have too many goods on the inbound side and not enough on the outbound side. Customers are unhappy. So it's literally taking that planning, that factory planning that has always been taking, most factories plan 2, 3, 4 months in advance. They know exactly when they can do a shutdown until there's a breakdown, and then they have to figure that out. And then it screws up their whole planning. There's a team on most factories of planners who figure out with supply chain when things are supposed to go in, when they're supposed to go out. So the whole challenge of we need to adapt dynamically to what's happening, and all the systems have to start talking to each other, because you might say, well, I need 25 goods urgently. Well, they need to go onto the production line sooner. Do I have the raw materials? How does somebody do that today? Excel and looking it up in SAP. In future, the factory will just decide, hey, I'm rescheduling, I'm changing the order, and I'm going to do this because I need to shut down that machine next week because I need to replace it. There's one challenge that I just want to bring up now to predictive maintenance. Every year, most factories shut down in December. And then they replace a whole bunch of components, if they needed to be replaced or not. Why? Because that's the way we've been doing it for the last 40 years. You always did that way. Now you come with predictive maintenance and you say, well, I can predict the stuff. They say, well, you know, every year I get new components, so you don't actually know when the thing is really going to fail because you don't have the historical data. So going into this dynamic maintenance where you don't do these shutdowns at the end of the year, it's something that industry wants to do, but they don't have enough data. And Industry 4.0 is really going to try and drive that to help them to do that. So as you see, connecting things is easy. It's the integration that actually becomes the nightmare and figuring us all out, and the business rules behind it. That's why industrial IoT, yes, connecting PLCs is fun. 90% of industrial IoT and Industry 4.0 is actually software, and guess where that comes in? Everybody in this room and the typical IT people, because that is again your space. Making those MES systems, ERP systems intelligent, making them work with each other. That's why, don't worry if you don't know how to connect the PLC. I'll explain it a bit later, but it's relatively easy. It's actually the integration and your code and that other stuff that you've been doing over many years that's the most important. Now, just for those who don't know industry or manufacturing, you've got devices. These are these PLCs at the bottom. And these are these PLCs, and they're in charge of automation and safety. And they only care in OT about safety. They don't care about security. They care about safety. Because when you press that red button to stop the machine because some human is going to get chopped up by this machine because the human's standing in the wrong place, you don't need to first, are you sure, yes, no. You press the button, the machine stops. The PLC has to immediately react. On a factory, you kill somebody, it's the biggest problem. You get hacked, okay, it's not that much of a problem. It's person getting killed is a bigger problem at the moment. And then, yeah, at the moment. But yeah, hacking devices is fun. Stuxnet, Iranian, damn, I can't even say this. Iranian uranium processing factories that were hacked not, what was it, 5-6 years ago. They attacked these things and faked the data on these things so that the control systems didn't know what was happening. But down here, this is hard. And this stuff down here, if it's installed on a factory, you will never replace it until you throw out the machines. You do not retrofit the PLC. You don't even software update the PLC unless the manufacturer says, update it, otherwise you're going to kill people because we've got a serious bug. So always remember what's down here, you cannot change. And if you tell OT to change it, they'll chase you out the room because you don't know what's happening in their world. Then the layer above that, those HMIs, the human-machine interfaces, the SCADA systems, the alarms, events, the historians, that is where data starts getting aggregated. Little secret, if you're going to do industrial IoT, it's easiest to tap the data in that layer. Because if you're going to start going at PLC layers, it's hard. I'll show you how hard it is shortly. Then the MES layer, manufacturing execution system layer, that is the brains of the factory that says, machine, you shall produce this now. Machine, run at this speed. I tell the SCADA system to do this. The SCADA system tells the PLCs, and the PLCs do what they are told. So the brains of the factory is MES, and the ERP is that thing that does the planning and says, hey, you know, that's why it's called ERP, Enterprise Resource Planning. It's sort of the accounting system, but that's what all the companies used to use for planning. So if you're going to tap data on a, let's say, proof of concept, proof of value, you do it here. If you're clever enough, you can do it here, but actually this HMIs, SCADA systems have usually got enough data to prove your point. Now, there is a challenge with industrial IoT. These layers are going to start collapsing because you can't have this hierarchy of this MES system telling the SCADA system, telling the automation system what to do. The logic is moving closer down to the PLCs. So one day you'll have PLCs who actually make the decision by voting with the other PLCs what's going on. So against what I just told you a few minutes ago, that it's easy to tap the data down here, if you don't understand PLCs long term and understand how PLCs work and their protocols and that, you're going to hit the brick wall where you won't be able to progress. So PLCs, it's not hard. It's a little PC with a bit of software on it. Some of it is running Intel processors. Some of it is even running Windows. You know, it's not hard. Some of it is running Linux. So just remember, industrial, you care about the stuff here, and these two systems add value to the data that comes out of this environment. So just always remember that. And I mean, these slides, you will get them afterwards. Use them as much as you want, that they make sense. And the benefits of Industry 4.0 is making reduced downtime, optimizing costs, plant performance, and figuring out what's happening across all the factories. There's a large food company worldwide. 4,000 production lines, 350 factories. Each factory has production lines, not inside even a factory are the production lines the same. Even though they were commissioned within a few months of each other, they've got different versions of PLCs, everything is unique. So in effect, they've got close to 20,000 unique production lines. Now try and do predictive maintenance on that. You need at least 20,000 models trained to do that if you're going to do the whole company. So just don't run into that direction. It's actually production optimization is where everybody wants to do it, because that is the lowest hanging fruit, and that's where you can do a lot. And here, that is for management to be able to see what's happening. In that food company, what they do is they take the input material information, the machine configurations as they are running then and now. They are taking the environmental conditions, and they are taking the information of the quality of the product coming out and storing that and putting it into a digital factory memory. Then, over time, they compare the various production lines with each other, including the factors, and they say, well, the problem on that production line is the shift that's on there is actually producing worse quality than the shift before it, even though the environmental variables and the settings were exactly the same. That's where they're starting to get insight into saying, hey, we need to train those people, or in that factory, in that country, it's better to run that machine at that speed, even though the manufacturer says it can run at the faster speed. Why? Because it's got slightly higher humidity. The people are the same, but it's actually not a people problem, it's actually a humidity problem. At the moment, they run all the machines virtually equally, and they don't know why some factories produce better or worse quality. So, I mean, just that. I still haven't talked to a PLC. There I've talked to the historian, I've talked to the manufacturing execution system, the HR system, and all the other systems. I'm not even trying to do predictive maintenance down at the bottom. I'm just reading what the historians and what all those systems have got in them. So it's actually a data problem. So forget that slide. You've probably heard about Opc Ua. Who here has heard about Opc Ua? Who here has implemented machines with Opc Ua? Okay, that's, for the record, that's 4 of probably the 20 people who've heard it. The challenge with Opc Ua is it's a great new standard. Okay, new, 7 years old. Siemens implemented on their first PLC end of last year. It took them 6 years until they decided, yes, we believe in the standard. Everything that's running out there is generally not Opc Ua. Opc Ua is a great protocol, I'll explain a bit later. But the old protocols that are out there, like BACnet, Profinet, Profibus, Modbus, all the good old stuff, the stuff that was even connected through RS485, serial connectors. Forget 232, 485. That is the reality. And connecting that is actually harder. Connecting Opc Ua is very, very easy. I'll show you shortly. We believe totally in Opc Ua. We're investing heavily in it, just so that you know, you'll see we're doing a lot of it, but the reality is there is still legacy stuff. So, we have brought out this Azure IoT Suite. It's the connected factory. Anyone worked with it yet? No hands, okay, good. An IoT suite is where we take a whole bunch of PaaS components, stick them together, spin them up using some PowerShell and some ARM templates, and you've got something that you can start working with. It's not a SaaS solution. It's not an IoT Central. For those who don't know, IoT Central is that SaaS solution that we announced that's coming out later this year. But IoT Central is not intended to be for factories or industrial automation. That's aimed at smart device manufacturers, like somebody producing coffee machines or compressors or something like that. Something where you have a product that's intelligent, that's got connectivity. Now, I mean, if you look at the connected factory, what it produces is some very nice reports. And anybody heard of OEE, Operational Equipment Efficiency, of course. That is the key to, that is what the factory cares about. How much time I'm spending with downtime, how much I'm producing, and how much of the products are junk, minus the total time that the factory was running, minus the total 24 hours in a day. And that gives you an efficiency. Most factories are running 60 to 70% efficient. You'd say, well, if you even just get it up to, let's say, from 70 to 75%, if you're producing 1 million items a year, imagine how much more production that is. So that's why operational efficiency is actually where everybody wants to go. This OEEs and these KPIs are the typical things that factory people want. So always remember, when somebody says OEE and that, refer back to this and say, hey, yeah, I know what that is. Because that's what, you know, is driving a factory. That's how you benchmark factories. Now, where's this data coming from? Microsoft has always said, Opc Ua is a big, big, big thing that we support. Opc Ua is a nice thing, but there's a challenge. It doesn't talk to the old PLCs and to the old things. Anything in the cloud, guess what? That's easy to replace. That's as easy to replace as you can get. Because it's in the cloud, take the component, replace it, throw it away, change it. If you decided to use stream analytics and want to move to functions, very, very easy. The problem is, anything to the left of IoT Hub, once you've made a decision on something, it's hard to replace, because it might be redeploying hardware, it might mean redeploying software, it might mean changing everything that's down there, and that costs money, because there you have to send somebody with a screwdriver down into a machine. That same food company on the production lines for the pet food, to get into the production facility takes you about half an hour, because you have to go through the security, then you have to go through a sterile environment, you have to go into another environment where you have to change clothes, then you go through another sterile environment, you have to wash again. By the time you're down at the factory, it's half an hour. Why? Pet food has produced to the same quality like human food. Why? Because there are humans who eat pet food because of the, they're too poor to afford normal food. I was also so totally surprised. For them, if they can reconfigure a machine out the cloud or outside that factory environment, or figure out we need to send an engineer in 2 hours, and they know that they need to do that in 2 hours, they can say, hey, engineer, in an hour's time you go into the factory, so when something's about to go wrong, you're there, instead of, oh shit, something's broken, send somebody in, half an hour until he's figured out what's wrong, brought the right tools. They've got a 4 or 5 hour shutdown. They can actually proactively send somebody in. And of course, the person can't live down in that factory all day long, because that isn't the way it works. So the connected factory is actually very interesting, because if you look at the Azure IoT reference architecture, it's quite different. The big brains is here. The rest, that's IoT Hub, time series insights, and a bit of UI. This is where the cleverness is. And the beauty of this is, you can take this pre-configured solution, pick up this here, switch off the simulators, and have this thing connect to your real-world PLCs. And what is this here? A Linux VM. So I can pick up that whole connected factory, leave the UI and the processing in the cloud, and I take that thing that does the simulation and does the connectivity, and I take it and drop it into the factory network. And as long as the factory network can talk to IoT Hub, either through AMQP or MQTT, or one of those two protocols over WebSockets, that Gateway Sdk, which has been renamed to the IoT Edge, can actually go and talk to your PLCs. So whenever somebody says, I want to do a POC, I quite easily say, okay, I'll take this VM, copying it down onto the network, and from there I integrate into that operational network. That's for Opc Ua. Now, just one thing before I talk on that. This is the Gateway Sdk. It is open source on GitHub. Cool. So you can take it and even take the compiled version out of the Linux VM and use it. Or you take the source code and you push it down and you compile it and you use it. Now, let's talk about something real. If you go to github.com, and if you look at the Azure, you'll see the you'll see the standard Azure device SDKs, but what's really interesting is the Edge. This IoT Edge is actually the old Gateway Sdk that's been renamed. And this Edge has got a whole bunch of connectivity to old protocols that you see in a factory. Opc Publisher and Opc Proxy talk the old Opc Ua classic protocols. That stuff that all those old PLCs talk. Modbus is also one of those that those old PLCs talk. So you can literally take this stuff, copy it down, compile it, and you can use that to start talking to your factory without using Opc Ua, because like I said earlier, probably hardly anyone's got Opc Ua. I know for a fact and if these drivers aren't good enough, you can go to someone like SoftRing or some of these other industrial driver manufacturers, and for a few $100 get a driver for those PLCs that you've got. This is the free stuff, that is the slightly more expensive stuff. So the Opc Publisher and Proxy, they're actually based on code that we submitted to the OPC Foundation, that we gave to them and said, here it is, and guess what it runs on? .NET Standard. That's why the stuff runs on a Linux VM also. Why? .NET Standard, nicely cross-platform. So all that stuff is well documented and, explains to you exactly how to do it. I'm not going to explain it to you now. Just one thing you need to remember. Opc Ua implements security down on the network. Your client, which is the thing that wants the data from the PLC, it needs to authenticate itself. What does it use? X509 certificates. You can switch it off, that authentication, but it's highly not recommended. The old protocols have got virtually no security. If you know what you talk to, you can go and suck the data and you can write to the PLC and tell it to do things. That's why industrial automation, the guys are so scared to connect anything to the internet, because if somebody starts playing with that, they can totally destroy the factory. In Stuxnet, all what they did was tell the PLCs, spin the centrifuges faster, but report normal data. So the things were spinning faster and faster, self-destructing, but the PLCs were reporting to the other systems, everything's fine. It's like having a kid. They always tell you everything is fine. And that's exactly how they destroyed it, because otherwise the monitoring systems would have said, spinning too fast, shut it down. So they literally bypassed it, and that is the worst case for a factory. Somebody starts changing the chocolate recipe at Nestle. I mean, it doesn't kill anyone, because it's still the same ingredients, but it tastes terrible. You produce a week of bad quality chocolate, you're in the newspapers and everybody knows about that. It gets worse. If you're a pharmaceutical company and producing insulin, you get that wrong, and instead of producing insulin, you're producing just water, you're going to kill a whole bunch of people because they think they're taking insulin. So you see how, you know, people are scared of this. That's why Opc Ua will help with security, but it just can't. So let me show you what I've got real world running at home. Sorry. This here is my little home rig. I've got a nice book, a Surface Book, which is my edge gateway, which I've got my dev tools on. This here is an HMI, human machine interface, in other words, a touch screen. The phone's an HMI. And this is the Siemens PLC. Notice network, network, network. There's a whole bunch of digital and analog connections on this PLC. This is a S7-1200. Anybody in industry has probably got hundreds of these in their factories. It or its little brother, the S7-300. This does not talk Opc Ua, but I bought it this year. It's like, thank you, Siemens, you still haven't given your old technology, the newest technology. No, we won't, because those things we don't want to change. So that PLC, what's it made of? A whole bunch of ports, a bunch of ports on top, power supply, Ethernet, and inside is a little chip, Symantec chip, which is similar to an Intel or an AMD chip or an ARM chip, but it's purely made by Siemens. And that chip is the brains. So think of this as super, super, super industrial Raspberry Pis with a nice case around it and costs €1,000. Yeah, it's an expensive Raspberry Pi. And plus a bunch of lights. But these things are certified, and you don't get things for cheap. So now, how do I connect this thing? This thing talks Modbus. So all what I did was take the Siemens tools, which they supply, the tier tools, and I pushed onto this thing the Modbus server. Because they don't install Modbus by default, because Siemens still believes in Profinet, which was their protocol. The German version of the protocols, they invented their own like in the 1970s, thanks to the German government. So Profinet is default on these things. I told the Siemens software install the Modbus server. I showed you before the Modbus server client on our GitHub repository. I use that and I tap the information out of this thing without any Opc Ua. And I'm running that Linux VM on that PC down there. Now here comes the problem where I said, if you don't talk to OT, you're not going to get anywhere. Why? Opc Ua is like a browser, you know, with a Windows browser where you can see all your machines and you can see drives and all that stuff. Opc Ua has got a similar browsing functionality where all PLCs say, hello, I'm here and I've got these parameters and I can talk this protocol and you can do this to me and this is the data you can expect from me. The problem with Modbus is there's no browsing. You connect to this thing, this PLC sits there and says, okay, and now you have to issue a command. And this command is, please give me coil number 3, the value. Okay, or give me the register 8, the value, please. You don't know what it means. It doesn't say it's revolutions per second. It doesn't indicate in any manner what the metadata of this is. Who knows the metadata of that stuff? The PLC programmer or maybe the machine manufacturer. So if you connect to these, you just get a whole lot of data and you don't know what the hell the data means. It's either bits that are on or off in terms of coils, or then registers with values in them. Cool. So OT might even not know that. So if you're going to try and do industrial automation from outside, you might have to ask OT to ask the original machine manufacturer to tell you what the hell they're doing on the PLC. With Opc Ua, I just browse to it and I start sucking the data, assuming I've got the X509 certificate. Same thing with Profinet. You don't know what it means. There's no units, there's nothing. That's why industrial automation is so hard. So yes, your customers will have this. So the first thing you say, I need the OT guys and I need the guys to help me decode this data. Because if coil 3 is set on, the output of the analog output 5 might differ to when the coil is switched off. Bit flipped 0, 1 has an indication what the other values might be. It gets, you end up with a matrix of 8 by 8, in other words, 64 permutations of what could be happening. Oh, beautiful. Imagine trying to write an if statement in SQL Server on that. If then. So just remember, stuff like this is hard. That's why did I say talk to the MES system? Or the historians? Or those other layers of systems above it? Because they've decoded it. So if you want to be hero and spend 4 weeks trying to connect to a PLC and decode the data, go for it. Hopefully the customer's paying you. If you don't want to be a hero, tap off the MES systems or off the historians. And that's the quickest way to start. Yes, eventually you're going to have to tap the data off here because you're going to say, hey, I need to get this data at 20 hertz off this machine because I want to determine what the vibrations are. And the predictive maintenance needs those continuous inputs at 20 times a second or 200 times a second. The historian doesn't have that data because they don't want to store so much data. But to start with a historian, because most of the time you find out in a historian if they've actually got the right data and if they actually understand the data. Now this is an ABB PLC that you use in the oil and gas upstream environments. You know, where the oil and gas comes out the ground, they've got all those valves. That controls the production, especially there in Oklahoma and Texas where you see all these. This is a Modbus PLC. It's connected via the internet, via a 3G network to the control room. There's no security. If you were clever enough, you could go and screw with this. And these things are in little white boxes next to the oil pumping station. These things are technically beagle bones. Technically, they're not far off from a beagle bone. And everyone says, oh, beagle bones, Raspberry Pis, they fail a lot. Actually, their biggest failure is somebody seeing this nice white box, shotgun, shooting the white boxes. It's a pastime in Oklahoma to shoot the white boxes. So why do they go and replace these things? Because they get shot up. Forget predictive maintenance. Send an engineer to fix these damn things. When these guys from ABB in Oklahoma in upstream oil and gas told me about it, it's like, no, you've got other problems. But this is like a Siemens PLC. 8 power in this case, they've got a bit of micro SD, they've got a bit of serial, they've got Ethernet, and the COM1 thing is a plug-in to talk various protocols. So if you plug in that a certain module on top, it either talks serial or it talks another protocol. That's how these things are built. For them, tapping this, they produce these things, they know how to do it. So if you're going to do industrial IoT projects and say you're going to try and work with somebody like Mars producing chocolate, you need to know, well, probably their machines come from Bühler in Switzerland, who are the chocolate machine manufacturing machine guys. Well, are they supplying data? Because a lot of these manufacturers are saying, you can tap the data directly, but we can also, and we can then supply it to you. So you might not even have to go to the historian or the MES system. You might be getting the data from the machine manufacturer. And that's going to be more and more. One of our customers, like ABB, you know, everybody knows ABB, that small little company. They're building their whole industrial IoT platform on Microsoft. And so eventually, when you need that data, you tap it off their system and not try and figure out how the hell to get the data off down here. And if it's oil and gas or wind turbine or electric vehicle charging or power grid or whatever. So yes, it's nice that we do all this hard stuff, but that's the way it is. So like I said, I take this and drop it locally onto the network, use the Gateway Sdk with the proxies and the client modules that are on there, and I start tapping the data. That's the easiest. Don't try and compile the stuff, because you know this damn frigging Linux VM works because it's producing data. All what you have to do is switch off the simulators. And that's also very well documented in the GitHub how to do that. So if I quickly go here, you'll see the connected factory dashboard, that's what it is. And this is the VM. This is the Linux VM that's running. Just one thing, something I've noticed. CPU average is over 100%. After running about 2.5 days, it somehow goes into a crazy cycle and starts going up to 100%. So it's like a Windows box. You need to reboot it once a day. No, sorry. I'm trying to figure out what it is, because I just noticed it about a week ago with the latest deployment. So I'm figuring out what it is and reporting it as a bug to the product group. But this thing here is that thing that is producing the data for this connected factory. So like I said, you take this VM that's running in your Azure subscription when you deploy this IoT suite, take that VM, put it locally onto the network. If the stuff is Opc Ua, out the cloud, I can start browsing. And that's one of the cool things with Opc Ua. We encapsulate that browsing protocol over our standard AMQP protocol. So you can like do a browse from the cloud against the PLCs on the network. That's assuming Opc Ua. If it's Modbus, you need to know the IP address, because otherwise, because it's got no browsing. And of course, if you need to connect this, because it uses a certificate, you just stick the certificate name in there and you then use that to connect. So, I mean, that's relatively easy. So out the cloud, you can start browsing a whole factories of network of data, assuming you've got rights in the various subnets. Instructions on how to do this are all here. I'm not going to walk you through it. There's too little time. But that's the beauty. We've taken something and we've, come on, don't take so long. It works. As you see, it's starting to work again because I rebooted that VM a few hours ago, and now it's going to start producing real data. Once this all goes down to 0, you know something's wrong. And now you can use this as your UI to show the customer, hey, this is the problem in this factory. I've drilled down to the data, and as you add more data, it dynamically adjusts itself and displays this data as it comes in. So if your PLC has a totally different data format to the simulators that we've got, it will automatically adjust itself and you can use this. So for a proof of concept, you take the VM, drop it onto the local network, you take the UI, leave it as it is, and you use that as your browser. for a proof of concept, you connect a factory in 90 minutes. You can do it quicker if they help you. But I literally had a bake-off with one of the competitors, and in 4 hours, I connected the factory, pulled all the data out. The people from another large company with a blue logo were still there a week later trying to connect. So just use this as a good stepping stone to start. And it's also, even for internal, start using this, because now you don't have to figure out, is this working or not? Just use this stuff and you know that it's working, and then you can start adjusting it. So the quick part of connecting things, if you've got Opc Ua, easy. If you've got Modbus, use the driver and use that. One thing that's, before I finish, is very important is edge. A factory's network has only got so much capacity. You cannot shove the whole factory's PLC information into the cloud. It's impossible. No one's got enough bandwidth. One of those food companies' production facilities we worked out would be generating 5 gigabits per second in a factory down in Brazil, 400 kilometers from Sao Paulo, where they're lucky to have 100 megabit internet. You can't shove it all into the cloud. So edge becomes even more interesting, where you do a lot of that processing locally on the edge, using stream analytics and the machine learning stuff coming in the Edge version 2, and then only the interesting data you send to the cloud, or you send the data to the cloud using FTP version 2. Does anybody know what FTP version 2 is? FedEx Transfer Protocol, where you take a hard drive, fill it with data, and ship it to a data center. FedEx and DHL and UPS, terrible latency, but incredible bandwidth. So always think you don't have to connect all the stuff continuously. You might take that data and shove it into the cloud as a batch to do the machine learning and learn what was happening. Always think differently. Just because there's IoT Hub there doesn't mean you have to feed everything through IoT Hub. It's ideal. I'd like it because you pay my bonus. But the reality is, in a factory, you're probably going to be sending data at irregular intervals via either some memory stick or some hard drive. And that's why edge will become more and more interesting, where you do all that intelligent work, where you take that data in the cloud, you analyze it, you process it, and you send the algorithms down to the edge, or even push normal code down to the edge and have it run down there. So just remember, the edge, down on the edge, will not be a Raspberry Pi. There's not enough power. It's probably going to be one of these Dell or Siemens or HP gateways, something like this. Last slide. There's more to this slide. Okay. You can take this. This is an HP Edge gateway with the Microsoft Edge technology in it, the Opc Ua and the Opc and the Modbus stuff. You take this box, plug it into your network, onto your production network, configure it to send the data to IoT Hub, and you can start sending data up. Because it's going to be using Edge version 2 in this hardware, it means that you'll be able to run that processing. So instead of saying, hey, let's buy some PC and put it down there, take one of these Edge things that you can buy from middle of November and use that, bolt that onto the factory network and use that as your local Edge version of your local Edge to connect to the cloud. And this will not be very expensive, and it will be supported by softing. So if you've got technical questions, you don't phone Microsoft, you phone these guys, and these guys are clever industrial automation people. So just to make it easier, so think of it as a step, because anything else is damn hard. When you've got time, look at this video. Not going to show it now. That's Tetra Pak, who's an OEM producing machines that pack milk, wine, and orange juice. See what they're doing with industrial automation and IoT. Every customer wants that. That's why if you need ideas, that's what you want. And just remember, security, 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 that's the most important. And if there are any questions, Are there any questions before I shut up? I'll be here for the rest of the day. Please come see me if you've got any questions. But thank you very much and enjoy the rest of your afternoon.